Hello, community. What is the performance difference between the new DeepSeek R1 0528 distilled down to the Q13 8 billion version if we compare this to the full DeepSeek R1 0528? Let's explore the differences in detail. Of course, we start here with the full version 671 billion free trainable parameter. We are back here at OpenRouter and we will test here the new DeepSeek R1, the latest version here, the 0528. Now, we could go here with an 8 billion one, but I think we will go here for the real version. So, let's have a look at the models. Here we have exactly what we are looking for, the 671B parameter size model. This is what we're going to take. Great. This is for free, request to the best providers, beautiful uptime, original DeepSeek R1 performance, yes, it's for free, so let's start to chat. Now what I will do is here a logic test. Let's have a look at this. It is easy. You are here in a skyscraper and you want to go from floor 0 to floor 30. Now there are some rules here. As you can see, I have here 5 buttons from A to E, and each button has a very particular function. Now, this is designed to make it really hard to have here a certain sequence of button presses that will bring you to floor 30. Plus, I also have here some trap floors. On those trap floors, you fall back again. So, it is a simple task, but it is designed in a way to make it hard for an LLM to come here to a logic causal reasoning. So let's explore what's happening if we start now. You see the reasoning process begins. Beautiful. And the first thing is here, it tries to understand here my wording. What are the functions here of button A, B, C? Exactly understanding here. Okay, so if I press this, what would happen? So the system is trying to understand here, to translate here my language here into something more efficient. Maybe it's going here for a mathematical formula or whatever. So if you move up floors, what happens now? Okay. Suppose the current floor, and now it's starting here to explore different solutions. It doubles the number if moved to this floor. Okay. I can test. I need to model it. There are trap floors, short sequence. Since this is a shortest path problem, I can think in terms of states and actions. Now, the floors are the states where you're in, and the action are the button presses. So you see, this is perfect for a reinforcement learning optimization. And yes, I designed the test especially for this. Okay, yeah, I have divisible for some modulo function. So let's list the button effects clearly. So you see, it comes now and says, okay, if I have a look at this, what does button A do? Now, let's stay here with the time so that you can see online what the thinking is doing. I'm familiar with the test. I've done it, I don't know, 20, 30, 50 times. So if you are new, this is just a standard test I apply now for more than a year to all the new reasoning models to understand what is happening in the reasoning. I read this in quite some detail to understand here the new modification in the reasoning structures. So let's have a look. If you say, oh, that's fast, never mind, you can scroll back, have a look at it. But you see there's a particular function now, how it tries here to understand what's happening. BFS methodology, beautiful. But it does not code here real Python code for the BFS implementation. It really tries to find it here in a logic deductive way, staying here within our linguistic boundary condition. So what happens if I press A, B, C, D, E? Beautiful. So it tries now out different sequences. It lands here on trap floors. It says, okay, it learns here exactly what are the problems here in this designed system configuration. And then it tries to come up with different solutions. List all floors first. Yes. Now it's thinking, you see, different combination. Now you can have different strategies. Now one strategy is you start at the end, you have to go to floor 30. So you try to find a solution starting at the end, or you start at the beginning, or you find different combination of button presses that give you quite a lot of jump on the floors. So you go, I don't know, half the way, maybe with a particular sequence of button presses. But I designed the test to make it really a little bit more complicated, you know. There's no easy solution if you want to reformulate this. Not yet, okay. So you see it's at floor 7. Now, what are my options to press here? What will happen? So from floor 7 onwards, so it starts here a logic deduction process here. So from 8 onwards, what would happen? I could press here a sequence of all the different buttons. Where would each single button bring me? So you see this is a simple optimization pattern it's applying. It's not using a tool to go to a Python environment or a solver that will solve this immediately within seconds. Even a C++ will solve this within 1 or 2 seconds. It is about the causal reasoning performance that I'm interested in. No? So from floor 11, now if you press A, you go to floor 12, B to floor 15, C, you fall down to floor 4, D 12, E 15. And yeah, there's a cost associated with this. And this is just more or less here. Beautifully, you implement here the reward function from reinforcement learning. Now, it goes here through all these different processes. We are now at floor 12 of 30. And you see it has its own thought about this. What about this option? Is it good? Is it bad? How fast are we moving? So it's really starting to do all the different permutation that you could find here if you were in a particular state of the system, and then you decide here to take a particular action. So it is not, if you want, calculating now the different probabilities for a particular action sequence, but it is just trying and learning by trial and error. If it would have done a better planning to have a strategic plan, like code, for example, and then have simply a mathematical optimization problem in front of us, we would not have to go through all this meticulous single floor planning. But if this is the strategy, we are now at floor 15, as you can see. Okay, let's do this. Floor 16, 18, faster. So you see this is here an inside. Okay, this is fast. Okay, this costs me this. Not necessarily better. So it's try to evaluating this. Now, what is interesting here at first glance is that it is not just coming up with one solution that is horrible in the performance. It says, yeah, I just finished somehow some crazy loops and traps and I come back from the trap. It is already trying to kind of implement an optimization. This is different from older systems. Older systems just try to find one solution with, I don't know, 100 steps, and then try to reduce the amount of steps. So they work here from one valid solution that is horrible in the performance, and then they optimize this. Now, this reasoning process here from this model is different. And even this one, the 0528, is different from the original R1 version. They improved causal reasoning quite significantly. You see, also we have some other signs beautifully. So, yes, in this sort process, it is now somewhere that it just switched here a language. Well, if it's easy, if it was programmed not in an English language, and it has the solution data in a different language, why not do this? For an AI, no problem. For me, real hard to follow. I'm not familiar with designs, but never mind. Let's just follow this through, because sometimes the reasoning process will end, and it is not 100 seconds as you see here. And then we will have the official final explanation how the machine thinks is the perfect hyperplane, is the solution here, and how many button presses we have to press actually. I'm loving it that it switches here to, I suppose it's mother tongue if you're an AI. that it was trained in China. I suppose this is here your native language. So I'll do the same if I don't speak so many languages, but if there's a real problem like to calculate, I notice that internally I fall back here to German because I try to, this is what I have been trained on for so many years. So it's interesting to see that the AI is doing the same behavior more or less. It's a pity because I would love to be able to read this. I can copy it and then ask to translate it. But let's just finish the system now for the first run. The reasoning is not supposed to be the real answer. We have not generated an answer yet. This is just the internal thinking process of this AI before it will generate an answer. And this is the beauty of the reasoning models and why we have reasoning and non-reasoning models. Because in a non-reasoning model, it just goes straight for one solution. And if this solution is a horrible solution in the efficiency, in the accuracy, never mind. You at least provide one solution. This reasoning here is trying to optimize its reasoning process. Chain of thought, zero shot, multi-chain of thought. We have different methodologies from, self-reflection AI systems. Absolutely fascinating. So what I can see, I would say we are here somewhere at floor 28, or maybe we try to go from floor 28 to floor 30. And it is trying, as you can see here, the different sequences of button presses, D, E, D. So we are at 7 button presses currently. Let's see if this is here the solution, what the system thinks. Okay, we have here this solution. Now reasoning is finished. Error processing stream. Oh, come on. Oh, come on. This is not fair. This is not fair. Yeah, it's a free resource, so yeah, I don't pay anything for this. Okay. So we have to start over again. Okay. You are here with me live. You see what I see. Okay. Yeah, whenever you work on absolutely free compute resources here for those problems here. Okay. So we start again. Okay. It would be interesting to see how much it cached here from its reasoning capabilities, but it seems we really start new. Look, this is the text where it tells us, hey, yeah, this is a simplification. It lands on prime. It's really currently trying to understand my English commands, and it's trying to get maybe a scientific notation out of this. Beautiful. So you see now it's trying to play a little bit around if it's get the idea. So from 0, press D, I go to floor 3, and it is now getting here. Beautiful, the idea. If I only press here the button D, where would I go? Beautiful. What happens on a trap floor? How far I fall back here? Okay. K-odd integers, yes. I avoid pressing A at particular floors to prevent being sent back, absolutely. So it understands here the functionality of my trap floors. Okay. So you see you have so many different possibilities to start analyzing this. This is now more or less the intelligence that is here in the encoded knowledge here, given the pre-training of this particular LLM. But I can tell you, really interesting is now a different, more in-depth reasoning process, especially now in the second version of R1, which is really interesting to see. So let's see if we can run through this in English. It would be great to see more, for me especially, since I try to understand the reasoning patterns. Yeah, it just goes through different sequence of button presses. Okay, back to minimum press. Okay. So you see, has a floor. If I press E, what would happen exactly? Where would it bring me? So it just permutates here all different solution. It is not, as I told you, coding here any mathematical sequence. It's really try and error. Hit the trap, not good. Okay. Skip this one, okay. So it's trying to find subsequences if you want, no? You can divide here from 0 to 30 and, I don't know, 3 segments and then try to find here the optimal subpath within a subsegment. So you reduce the complexity of the complete problem. You have then 3 main problem and then you find here, try to find here sub-solutions to the subsequences. I don't know if this is the way forward, but currently it looks like AI is trying to implement this. 8 move sequence at 11. Okay. Yeah, it's just trying through. You see, from 0 to 14 with E only. 7 moves to 14. Okay. Then if I apply button press A, brings me there. And then D. And then 9 moves bad. That's not really happy with this solution. So it is self-reflecting and it is correcting itself. And there was a question why I do not ask question here in the reasoning process. I have such designed a complexity that given now this complexity, the AI itself is reducing the complexity and creating multiple sub-complexities that kind of interact and have an interdependence. So the AI is completely really running here its own complexity interaction pattern. I don't need to ask anything. I know for you just watching this is not entertaining. There's no action happening. This is not a video of a cat or something. This is just watching here the internal reasoning process of an AI. You see, try to minimize now the moves. Press A at a high number of floors. This is an interesting idea. It is trying to find sub-solution. It is not trying to find a complete solution. Okay, can I get to 18 faster? 6 move as above. Is fixed with D. Other bottoms, not better. Number of presses, 8. Is there a 7 press sequence? This is now interesting. Now it starts to optimize here before it gives you here the answer, which is great. You see, this is here where all the resources during the reasoning process go. Only 6 presses. Is that possible? And here we have a sequence already. You see, from 0 to 30. So from bottom to end. Beautiful. Better than 8. Earlier I missed this. No problem. So you see it goes here again and again, tries continuously to self-improve itself. And as you see, this is just a simple riddle. No? There's nothing specific, no complexity landed here. 15. I land on 13. Okay. Hello. Oh yeah, here we are. Yeah, it's a free resource, so I'm happy. Now we are back here. Now we have creation of the answer. You see? I guess it will be 6 presses. Yes. Total presses 6. Those are the features. Why is this sequence optimal? Avoid inefficiencies. Okay, that's great. Avoid here the trap floors. The floors 13 and 22 are never landed on, ensuring no forced movements or restriction that could increase the number of presses. And that gives me here, this sequence is optimal because it minimizes here the presses by combining the strategic use of button A for a large jump with the consistent upward movement of button E and D. So our sequence, as you see, is, yes, beautifully, the main part of movement happens here from 11 to 23, and then we have a little bit of fine-tuning that we reach D. So the bottoms are D, E, A, E, and D in order. So, let's do this. So now I tell the system, hey, evaluate your solution. This is the solution it found. This is a 6-step process in order and show me step by step that this is a valid solution of my query. Now, some of you ask why you ask this, why you want a validation. I want to see the reasoning process during the validation. Now, I know it already did it and it is rather simple, but the question is, does it have a reasoning process now in the validation? So is there now a higher entropy that we can encounter now in the validation process compared here to the finding process? You see, is this the shortest? And here we have it. The system is now, and this is new to the latest version of R1, even in the evaluation it is trying to run an optimization. An internal optimization within the reasoning phase. It's not providing you, up until now, any answer. Absolutely fascinating. Look at this. It is trying to optimize it. It has found a solution, a very good solution, maybe it's even the best solution, but it is not satisfied. Now, this is interesting. Now, on the one side, this is positive because you can be sure now that the reasoning process is now so deep ingrained here in this system that it always tries to optimize it. But my task was not given. What I wanted it to do is show me the validation. But I did not specify I don't want another optimization run. So it does here inherently has another optimization run, which is good if you want the highest performance. But if you have to pay for this, I would then recommend you put in your text and do not have another optimization because, yeah, you have to pay for this. Better to avoid. Another idea from original sequence, we use A at 11 to the step 23. You see, this is here our biggest jump in the sequence. 23 is prime, but not using since pressing C. So are there other better solutions? Back to 5 presses. Is this possible? And now we have here official answer. Just let it run through and then we have a look at it. So you see, it is thinking, and reasoning. And there is now the question, at what time does it stop to try to optimize it? Because we have to pay for this. And I think here with the R1, it is just to optimize the reasoning, no matter what it costs. This is great for performance. But if you have a tight budget, you have to be really precise in the formulation of your task. You see, it tells us a failed 5 press attempts. It is trying in the evaluation of its solution to integrate further optimization. Conclusion. This is valid and optimal. So let's have a look at the beginning. Let's see what is now the final answer. And I think it's more than 130 seconds because this was 5 or 10 minutes in total. So the proposed sequence starting from floor 0 has been evaluated step by step. Full validation of the path. Beautiful. Starting from floor 0. D, current floor, next multiple movement, next floor, trap checked, is not a trap floor, continue. Beautiful. If I see this, I trust the system because, okay, it understands the rules, it understands the constraint I applied here on the system for this logic puzzle. Beautiful. Additional check is prime, does not affect here button A, only button C cares about primes. So it even understands and it checks at each step here the complete set of constraints. Beautiful, achieved summary of the path. 6 presses, and we know from the other tests, 6 presses is here is the best, is the shortest path. But yeah, we could ask now, is this the only valid solution? And I designed my test that we have a degree of freedom left. So this is not the only valid, but more about this later. Negative conditions avoided, no bounce backs, no prime related bounces, no subtraction issues. Why is this perfect? Reaches the goal. Fully respected. Button D was used correctly. Button E was used only when the current flow was odd. was used safely. Yeah, beautiful. The trap floors were taken care of. Path is direct, no backtracking or unnecessary movements. Beautiful. Optimality of the solution. Sequence with 6 presses is optimal. This is the shortest path. Minimum presses. Realistically, less than 6 presses is nearly impossible. And it tries to give you even here a logically sound explanation. Yes, it tried here 5 presses attempts. Beautiful. Avoid this for smaller step. Yes. But no, the original sequence is optimal. Absolutely. No shorter path found. Is valid and optimal. Optimality, efficiency. Real beautiful solution. You see, this is here the solution pattern. But did you notice that it did not start here with any wild solution? It applied an optimization right at the beginning of the reasoning process. And this is a new feature I have not seen before at R1. So here we are now with the Q13 8 billion. And you know what we're going to do? We do exactly the same test. We are here also in a skyscraper. We have an elevator system. We want to go from floor 0 to the top floor 30. And we have button A to button E. So we have 5 buttons. And each button has a particular function to move the elevator up or down. And we have here a further challenge. We have 2 trap floors. And you just fall back if you land on one of those trap floors. So let's start here this logical puzzle now with the free version and the 8B version only. As you see, we are here live. Let's see here the reasoning process. Interestingly, it runs faster, which, yes, of course, it's only an 8 billion free trainable parameter model. Let me confirm. Should consider floor 0 is start, yes. I can think in terms of model or something to simplify. This is nice. Yes, okay. But the challenge is to reach floor 30, avoid weapons or save up. Okay. Not needed directly. Let me try to find a sequence to 30. Okay, now the different buttons up. A, E, D, yes. Let's consider pressing here the different buttons. Okay. Perhaps use buttons that can jump higher. Beautiful. This is button A, absolutely correctly identified. Perhaps a strategy. Use D to reach multiple of 3. Then from there use A or E to increase faster. This is interesting. So you see it tries here different strategies. You always move at least 2, and if condition, double the amount moved. Okay, invalid. No, yeah, there are traps. I decided this is not that easy. Not helpful. Okay. Back to floor 6. Yes, there are trap floors exactly for this particular reason. I can reach, say, floor 20. And then, yes, there are different solutions. It tries now modular operation. Okay. We are back here to permutation. Oh, we have an answer. This was quite fast. This was quite fast. Absolutely impressive. You see that there is a difference in the performance. Hey, this is really interesting. Okay, so this is the answer. I just want to give you here now the final answer. Solution to the skyscraper. Yeah, starting here. And it gives you exactly floor 0. Press button D. Then we go to floor 3. No rules, exception apply, and then we go all to different button presses. But do you notice something? Now we have a path that has 10 presses. So the reduced distilled QN3 8B from the R1 reasoning traces finds a solution that is not the optimal 6-press solution, but now a 10-press solution. This might be a correct solution, but it is not the shortest path. And the shortest path is defined here as one of these conditions. So the path is unaffected by additional rules, yeah? Buttoned explanation of the optimal strategy. From an 8B model, this is interesting. Button D is the key. Okay. Why 10 presses is minimal. This is incorrect, but for a small system, this is good. Floor 30 is a multiple of 3, so reaching it from floor 0 via button D requires a landing on floor 27, yes. Oh, okay. Yes, no, this is not the correct strategy. Have a look at this, read it yourself, and maybe you have to write it down. I have done this test now, I don't know, 20 or 30 times, so I kind of have a feeling for this test. If you're here new to my channel, you might need to read this step by step. Avoiding the trap floors, yes. Avoids both floors entirely, make it robust, this is great. Comparison with other potential, this is nice. If other buttons were used, mixing here button A or E, the sequence could be longer. Okay. The UFD sequence is the most efficient. For a small model, this might be a valid statement. For the huge model, we saw, no, this is not the right strategy. It is one strategy, it's a valid strategy, but it is not solving the shortest path problem. So, our final answer, the shortest sequence to reach floor 30 uses 10 button presses, all with button D as shown above. This is optimal, yes. So, it found one strategy. You see, this is the beauty if you have a variety in your entropy classes of the solution. Of the sequence of the solution path, if you go from a state, you evaluate the probability functions here for particular actions. And then this probability function, if you have not enough entropy, you fall into a local minimum. It is not the real global minimum, but you find already, you find one valid solution. It is valid, but it is not the perfect solution. So you see Q13 8B, it is good, but it is not as good as the full model. Reasoning, yes, okay. Maybe you do this, you copy here the reasoning path. This is what I do regularly. And then I ask an AI to analyze here the complexity of this reasoning path and find me common patterns. We can do this if you want. And so I say now, hey, analyze the solution path and find different solution patterns. What did you notice? Did it enter into loop? What was special? And now we just insert here the complete reasoning sequence here. So our little Q13 8B model is now syncing. It would be interesting to do this with a pure Q13 8B without the distillation from DeepSeek R1. But whatever. Okay. Do you notice that it is already trying to optimize here another solution? This is unbelievable. I think 10 is the minimum. It is not really doing what I told it to do, to analyze the patterns, but it is already trying to further optimize it. I was not absolutely precise in my wording, in my query, in my task given to the AI system. Okay, no better, not direct, another button. It's not doing what I told the system to do. It is further continuing trying to find optimization solution. So did it find another solution? Yes, it found a 7-step solution. Impressive. To go from a 10-step to a 7-step solution is, for an 8B model, absolutely impressive. So, solution. The goal is to reach, after analyzing all possible sequence, the shortest path uses a 7-button press, step-by-step sequence of the floor tracking. Okay, it's not what I asked it to do. Why is this the shortest and most effective path? Optimality, efficiency, trap floors. extra layer of complexity or the trap floors. So I say, hey, you did not perform my task. I ask for an analysis of the reasoning patterns in the prompt. You further optimized the solution but failed to provide me with the insight on the specific reasoning patterns. Can you do it? So let's see. We are the free solution, so thank you so much. Okay, here we have the response. But it was edited. Presented as if start. I need to I apologize and okay. I have to read this a little bit later. Let it just run through and then let's see what is the response. Maybe you can read this here in real time. I don't. Pattern description, synthesis, pattern description, why these patterns are effective, final insight, my reasoning. So let's start at the beginning. I apologize for the confusion. I focused on providing a solution to the logic riddle with explanation, but I did not fully address your request for analysis of the reasoning patterns. I should specifically analyze the reasoning process and the patterns. I will break this down step by step. Okay. Handle additional constraint. My reason followed several key patterns. Stepwise and incremental progression, the greedy approach. Breaking the problem into smaller, manageable sub-goals and solving it by steadily increasing the floor number step by step. Okay, I understand why. Example, I understand it. Rule-based reasoning and parsing and ambiguities. The pattern involves meticulously interpreting and applying the given rules to each button action. It requires handling ambitious or undefined cases and ensuring all movement comply with the rules. Sometimes convoluted rules. Yes, of course. Optimization and search for the shortest path. Yeah. Finding the most efficient solution by searching for a sequence with the smallest step count. Involve backtracking, comparing multiple options, greedy dynamic choices. Absolutely. Why used here? Constraint handling and loop avoidance. Specific rules. Avoid trap floors. Constraint must be avoided or handled separately. Prevent loops or forced resets by ensuring the path doesn't land on dangerous floors. Okay. Synthesis of multiple strategies. They are not really complex strategies. No, there's a basic strategy, I would call it. Yeah? Combine various approaches. Beautiful. Not sticking to one method and adapting based. Okay, why these patterns are effective. Stepwise progression and rule-based reasoning ensure the accuracy, while the optimization and constraint handling prioritize speed and correctness. Synthesizing the strategies allows for flexibilities. Final insight. While not guaranteed for larger variants, the patterns here work for this scale due to rule-aligned behavior. If the riddle were expanded, these patterns could be adapted but might require computational methods or more formal analysis. Absolutely. A mathematical solver would be so beneficial here because it would solve this within 5 or 10 seconds. But you know what we're going to say now? I say, can you further optimize yourself and find a 6-step solution? Try it. My little 8B system. If I get the free resources. So you see, okay, I have a 7-step sequence so far, but now I need to find a 6-step solution. Current solution is this. Can we reach this in 6-step? Let possible sequences be listed. Okay, so we just have more or less a trial and error system approaching. Okay, not bad. Okay, at least it's trying here. Now that it has already a stable solution, should be no problem at all. So, what's happening now? 7-step, okay. This is interesting now. You see, since the entropy here of our probability distribution are not really strong enough to break out from predefined solution path, the answer given here to us is, after re-examining the problem and the reasoning patterns I conducted to find a 6-step sequence, initially I found a 7-step. However, I evaluated possible sequences. The key patterns are employed. Beautiful, yes. After exhaustive testing, I found no 6-step sequence. So to the best I found is a 7-step sequence. So you see, this is kind of a limitation if you do not go with the full 671 billion free trainable parameter model. Of course, if you break it down to an 8B, there must be some reduction in the capacity of handling higher complexities. But honestly, an 8B model that finds a solution here is absolutely impressive. Good work, great job done. Total button presses here given. Okay, trap avoidance, yes. Failed attempts. You see here 3 failed attempts. Okay, so it is not that it's not able to solve it, but just it is from the system capacity in this particular trial and error, it was not able to do it. Just that you know, if we start new and we run this another time, and then we start new and run another time, there's a good chance that it will find here a 6-step solution. But you just have to be aware that it will take much longer, and it is a little bit of, an accidentally finding. It is not there that it is really computed here in the complexity, but if you are lucky and you have the right boundary condition, even this 8B model might find here the correct solution. I hope you enjoyed it. I see you in my next video.